we're now going to look at the indeterminate form infinity over infinity. And our book doesn't write out L'Hopital's rule including infinity over infinity, but L'Hopital's rule can actually be extended to work exactly the same way it did with 0 over 0 when we get infinity over infinity. We're still just going to take the derivative of the top over the derivative of the bottom and try to use that. So the reason our book doesn't include it right away is it's a little harder to prove. But since we're not worried about the proof so much in this course, the actual applying it doesn't change. So we're going to look at the limit as x goes to infinity of natural log of x over 3x squared plus 7. So if we think about the natural log of x, as x goes to infinity, the natural log of bigger and bigger numbers just keeps getting bigger and bigger. So the top is going to infinity. And if we think about 3x squared plus 7, so that's a parabola that's facing upward. So as x goes to infinity, that's also going to infinity. So we can apply L'Hopital's rule. And when I do something that's applying L'Hopital's rule, I'm just going to write a little L apostrophe H. So L'Hopital's rule says this is the same. It's equal to the limit as x goes to infinity of natural log of x. So we're going to, the derivative of natural log of x. So 1 over x over the derivative of 3x squared plus 7, so 6x. And from this point, we're just going to do a little bit of algebra. And so if we simplify this expression after our limit, so I'm not doing L'Hopital's here, I'm just simplifying. It's going to be the limit as x goes to infinity of 1 over x times 1 over 6x. Remember, when we're multiplying, we're going to multiply across the top and the bottom, so this is the same as the limit as x goes to infinity of 1 over 6x squared. Okay, now this is a limit that you would have been able to do before you learned L'Hopital's rule. Here the numerator is staying 1 and the denominator is getting bigger, bigger, and bigger. So you could kind of think of this like 1 over infinity, but we know that actually goes to 0. So our original limit, the limit as x goes to infinity of natural log of x over 3x squared plus 7 is equal to 0. And what this really means mathematically is that the limit of natural log of x is going to infinity much slower than 3x squared plus 7. Since 3x squared plus 7 would be going to infinity faster, the denominator would be getting larger faster, so the whole thing is going to 0.